Hey guys, welcome back again. I'm reporting on the earthquakes in the last few days once again. I guess my last video was 2 days ago. I'm definitely not going to cover every quake that happened in the meantime. The one thing that I do want to cover that I put a post on, I think on YouTube and probably on Facebook about... I definitely need to centralize this somehow. I probably need to start a Telegram channel, and I don't know. I'll become a genuine content creator someday. But in the meantime, I'm more of a numerical or computational physicist or whatever. But speaking of which, my latest correlation, that's the word I keep using for this channel, my latest earthquake correlation. Okay, this is the quake that just struck right now. I guess, what? Is that like 1 hour ago? I'm thinking, but pretty recently in Afghanistan, right? It's 4.4 quake. And here's my usual geodesics going within 0.1 degrees of two other quakes on the map. Let's see, one selling point, I finally did add some mouse over capabilities and clicking capabilities. No more tedious typing in numbers. So we can see that this quake, this geodesic that goes through Afghanistan also goes through Alaska and Pakistan. And I could probably stand to add some more info like the... Actually, I've got the other info over here. You can mouse over the quake and... Assuming that's the right one. There's 4.2 in Alaska. Port Ellsworth, Alaska, is that R? Maybe let me make this bigger. Is that our... No, Chiniak, Alaska. It's going to be one of these. There, Chiniak, 2.7. And the other one is Pakistan, here, 4.4. Ooh, one of them was 4.4. And this one's 4.4 also. Weird. Just saw 3 out of 4 4.4s. But, so here is one geodesic within 0.1 degrees. Here's the other. Is this line that goes Fort Irwin, California, and Carlsberg Ridge. Is this Carlsberg Ridge? Yes, in the middle of the Indian Ocean. 5.4, and then California over here, right? 3.2. So my latest discovery that I've been ranting about. Oh wow, look at that one. It doesn't even... Like, that's not 0.1 degrees, but that's definitely, that's definitely significant. There's multiple quakes here. And also, wow, this is impressive because recently I've seen a lot of quakes with geodesics making plus patterns and X patterns. And I've been posting a bit about, hey, this is how gravitational waves work. Maybe gravitational waves are related to geodesics. But for all the quakes with geodesics going out in different patterns, I don't think I've seen an antipode quake until now. I have heard from other channels that it is a common thing, that there's some kind of statistical correlation with quakes and their antipodes making quakes, but I had never really seen it until now. In fact, I always thought it was kind of a anomaly that every time I saw a quake, I would not see an antipode. But here it is. So here's an antipode quake going on. Wow. Southern East Pacific rise. Interesting. But either way, I didn't want to draw attention to that. That's interesting. I wanted to draw attention to... So we have this plus pattern, right? And I just kind of recently was connecting dots about these plus and X patterns correlate with gravitational waves. But there's something else that I just noticed recently about this quake and a lot of others that I'm going to go through in this video. And that is, let's change to my favorite flat earth mode. And just align this to, let's see if my mouse controls can handle this. To, this white line you see here, okay, all these colored dots, those are the planets. Those are where they are directly over at the time of this quake. And the white line is an approximation of the orbital plane of the solar system. I'm just kind of winging it. I think I just added a few cross products of angles between planets together and came up with an axis. I should probably use something more certain, like maybe, I don't know, the sun's, I don't know, one of the sun's vectors or something, or maybe a total angular momentum vector across all the planets weighted by their mass. I don't know. I'll think of a better approximation later, but or even just who knows, just God forbid a least squares regression, because I hate statistics so much. But here is the orbital plane is the white line that's in a loop around our flat Earth model that goes through all the planets. And notice that these quakes, you have get this kind of a plus pattern, and at least two of them are going perpendicular to the solar system plane, and the rest of them are going very close to parallel. And keep that in mind, because we're going to see that a few more times as I cycle back through these other quakes. So here, Afghanistan. Next, we have Oman. And what do you know? Once again, we don't have any... actually, I should say, within 0.1 degrees, we do not have any perpendicular geodesics. However, if you just look at this... I don't know how to pronounce that, somewhere in Russia, and then Alaska, central Alaska, I bet if I made the parameters a bit more loose, you would, in fact, I might as well go do that right now, right? So let's try 0.5, there it is, perpendicular to the orbital plane again. And the other one that we saw here, which was 0.1, right? Let's go back to our previous threshold, 0.1. The only thing within 0.1, which is incredibly tight, it's too tight to find a whatever kind of rough model I should be looking for. But I'm doing it just to prove a point. I keep repeating that. But either way, within 0.1, 3 quakes in a line, Oman, Indonesia, Solomon Islands, and this is pretty close to parallel to the orbital plane line, the white line. And that's a pattern we just saw here in Afghanistan, and there it is in Oman. Let's keep going back. Let's see how often this happens. This, I need to work on that mouse movement. This is not quite, okay, there is a tilt that shows up in a bit of these when I'm looking at this pattern. Because here we have an X pattern, and it's not exactly at 45-degree angle, but it's pretty, I don't know, it is close. There's something weird about this. It's probably not exactly what I'm looking at, but there's still some weird correlation here. In fact, keep that tilted angle in mind, because we're going to keep going back. And depending on where the quake is, it's kind of harder to line up with the solar system orbital plane. But nonetheless, this is pretty close, once again, to our tight geodesics going through other quakes. Just happen to be pretty close to slow computer, pretty close to perpendicular to the orbital plane at the time the quake strikes. And here we have, let's try. I suspect, okay, I'm using flat Earth mode because azimuthal mode, because that's going to show our geodesics as straight lines emanating from the quake we are centered on. Of course, all the other ones are not going to be straight lines because we're in spherical or WGS84, or if I add the geoid map, the geoid model, right? So there's no perfect shapes going on here in nature, but I'm coming as close as I can to our straight lines on curved surfaces, right? Squaring the circle or whatever, circling the square. But here's another one that, it's not quite perpendicular. I suspect you could draw a parallel line from these guys. Let's try again. Let's increase the threshold and see if we don't get. It's getting closer. I'm sure I can get these two on a straight line, and even this one, now that I've increased the threshold to 1 degree, we've got multiple that are running pretty close to, once again, pretty close to perpendicular to the solar system plane, and we have this future quake. Remember, the whole goal of this software, of this model, is to find future quakes. We have this future quake on a geodesic with this current one on a geodesic that's parallel to the orbital plane at the point of the current highlighted quake, right? Let's keep going back, because there's some even better demonstrations of this correlation. Here we have, for some weird reason, these North and South American quakes, they're always at this, I won't say that they're at this tilted angle, because so are the planets, and I'm still trying to decide in my mind where exactly the closest point to the orbital plane is going to be. It just might be, I don't know, maybe it even is like something close to this. I don't know. I should do some better math and find out. But either way, you'll see these, like the America quakes are very often kind of tilted at this angle. But nonetheless, this is still kind of a weird plus and a cross, plus cross and a X, even though we only see kind of one diagonal of the X going, but everything's still kind of tilted. Never mind this one. It doesn't really fit the bill. But then we have this one. And then once again, it's pretty close. It's still kind of tilted, but it's still weird that these geodesics are they're forming one line and then another one that's off at a bit of an angle. Still not the best example of what I have been observing. Let's keep going. And then once again, the Oman quake. And we just saw the last one, which also made geodesics through these similar lines, right? Interesting that this one has these two future quakes that are about to come that are also even closer to the geodesic, or to the parallel of the solar system orbital plane. Very interesting. The solar system orbital plane is kind of dropping us hints at where the geodesic that points to the next quakes is going to go. And here sort of is that plus and cross shape. Hint, hint, I'm leaning towards gravitational waves, but fun aside note, every single professor I've ever talked to about solar system level gravitational modeling has just laughed it off, even though they themselves didn't possess the skills to even make a GR simulator in the first place. If you look back at my YouTube videos, yes, that is my background. No, I have not been successful in getting a PhD at it because professors they either have egos enough to prevent themselves from accepting me to their programs, or in at least two cases that I have been accepted, there's corruption. Yes, that's right. There is mismanagement of money that should go to me and didn't. And in this most recent case, I was just kicked out of uni for not paying the bill while the grant money didn't get to me. So yes, two cases of corruption involving advisors. And that's another reason I haven't got a PhD yet. But back to the gravitational simulations at the solar system scale, lots of professors have told me, have even laughed at me at the thought of making anything smaller than a black hole mass worth of gravitational simulations. Meanwhile, I point out to them things like the Elias effect, I'm probably mispronouncing that, the Foucault pendulums that wobble during total solar eclipses. I point these out to them, and they either say, I've never heard of that, or they say, I don't believe that's real, or a little bit of both, even though this Elias effect has been observed how many times in the last 120 years. It's definitely a real thing. There's definitely some kind of suspicion or some kind of mysteries to how gravitation works in the solar system scale. Heck, fun fact, we are pulled into the Earth because gravity works at the solar system scale. I'm sure that there probably are some GR, if not GR, then GEM scale effects that go with that. Fun fact, the gravity probe B verified that the parametric GEM effects, or I guess those are two things. Parametric is a spinning, what do they call it? Strong regime, metric, spinning spherical object. GEM is the linearization, the Donder-Gauge linearization of the Einstein equations that happens to make the Maxwell equation, or something, up to a sign difference in a single term equivalent of Maxwell equations pop out. have some added force terms, your gravitational and your gravitomagnetic effects. But either way, we know that more than just Newton gravity happens at the solar system scale. To what extent we don't, or to what numeric extent, it's like 0.00001. In my old solar system webpage software that's down at the moment because it's too much data to host on free sites, and I'm too poor to host it, to pay for hosting fees. That would show you the difference in magnitude of like Newton versus Schwarzschild versus Kerr, and it's just incredibly small for linear gravity or even for tidal effects. But that's just measuring what's pulling you into the Earth at that one point, right? We don't know what's going on inside the Earth, and especially in terms of motion. We are slowly mapping, what's there in terms of density. But so I'm gonna always have gravitational effects in the back of my mind just because that's my background. Of course, more likely, and I think a lot more earthquake predictor folks are probably going to lean towards electromagnetism. I'm definitely not discounting that. There's this correlation with high earthquake magnitudes like 7 point plus and high flares like M or X class flares, and that was this famous Nature publication from like 5 years ago. So yeah, it could be electromagnetic. It just might slight in the back of my mind, just might be gravitational or tidal, Riemann curvature tensor or geodesic tensor. Geodesic tensor, connection coefficient, geodesic equation, force function. But we'll see what it is. I'll crunch numbers later. I'll keep going through these quakes because I still haven't got to my real demonstration of the effect that I'm pointing out here, and this is probably pretty close to it. Though, funny, this one at least looks like it's going perpendicular to the orbital plane, almost plus or minus. And then once again, that parallel to the plane. And that perpendicular one is at this weird off tilt, which I was saying all the American quakes had for some North and South America for some odd reason. But keep going back. This one is a little closer to parallel, especially this geodesic through these incredibly small earthquakes. What's that go through? Indonesia on the other side of the world, and Alaska, and Chile. And America with its weird tilts, and Indian Ridge. And this one, yeah, whenever they get kind of too offset from the orbital plane like this, then they don't exactly form that clear plus or X pattern. Interesting that the leading geodesics here do happen to go through Mercury. Would that be a case for the EM influencing quakes, maybe? There was another paper that was just, I think 6 years ago, about the magnetic fields of, I think it was Jupiter, Earth, and was it Mercury or Venus? It was like the 3 strongest magnetic field planets in the solar system, and how their 3 orbits made this 11-year periodic influence on the sun, and that was the author's conclusion of why our sun has this 11-year solar weather pattern to it. But who knows what else that those planets are doing to the quakes here. And here we have Mercury. Let me just double check. Draw Mercury. Yep, that's it. So Mercury is in line with these quakes. Interesting. And there's another American quake. This one is close enough to the axis. There's no geodesics unless I up the threshold a bit. Might as well. And there's some kind of weird like plus and X almost pattern. These are not quite added, 45 degrees. It doesn't look so clean cut, but they do exist, and they keep popping up like so. And Yeah, these guys are always, Americas are always at a skew angle. I have to figure out why. Keep going. Eventually I'll get to, oh, there, this is a very nice, so there's, this is kind of like a plus pattern. And once again, this is skewed, and so is the orbital plane. Like I keep saying, every time the orbital plane is at this weird angle, so is the parallel geodesic. What is going on? I have to think about that. Maybe it's just the location on the Earth and the fault lines, you know. This whole geodesic thing is too weird for me to discount just yet. There's a great example, though, of, you know, once again, let's get it like so. Once again, because it's America, the perpendicular one is not so perpendicular. However, the parallel one is pretty darn close to parallel. We have this parallel geodesic and we have the orbital plane. The parallel geodesic goes through Papua New Guinea, Hawaii, and Puerto Rico around the world. I think there's two. There is. The other one, same. So just kind of two through two different quakes in the area. And just keep going. There's another one that is at some kind of odd, weird angle. I'm going to just kind of skip that. Same with the American one. Skip that. There. This one has a perpendicular line going through these weird quakes in the middle of nowhere. And going through this future quake in Afghanistan. And Fort Irwin, California. So yeah, perpendicular line to the orbital plane. That's the whole point of this video, right? I'm just going over these weird quake patterns involving the orbital plane of the solar system. And granted, flat Earth azimuthal mode is probably not the best way to demonstrate it, because who knows, maybe this is actually a lot closer to the orbital plane than I see on this weird projection. Nonetheless, there's your other weird plus pattern. And I don't know, South America somewhere. And here, I think that this was another one of my classic examples where this is definitely looking perpendicular to the orbital plane. Like this one right here, right? Oh, and what do you know? There's Mars. How many times did Mars pop up on Geodesics in the last few videos? And it probably did in these ones, and I haven't even been really kind of looking for it. Nonetheless, weird patterns. Here's another one that's similar, not exactly at that point, similar to the orbital plane, not exactly. And another one, once again, not exactly, but similar. Maybe I should be double checking my ephemeris transformation to go from Earth frame to whatever the ephemeris data. I'm pretty sure ephemeris data is in the Earth frame. Yeah, I'll have to check, but I'm pretty sure it's centered at the sun with the basis for the Earth averaged equatorial or something like that. Let's keep going. Slow computer. There's the infamous plus pattern once again. Perpendicular and parallel to the orbital plane, almost. I'm suspicious my planets are off. There's the plus and almost the X, that weird North America pattern. Keep going. I really wanted to get to this one. And there it is. And this was my classic aha moment when I looked at this quake in flat Earth mode and noticed that all the planets were conveniently lined up right underneath it. And I thought, wow, that looks like it is both perpendicular and parallel to the orbital plane. And so there's my most recent, most like famous aha moment, that these geodesics that I'm noticing that are 3 quakes within 0.1 degree alignment. Now I'm noticing that very often, not always as you saw, but very often they are forming geodesics both perpendicular and parallel to the to the solar system orbital plane. And if I keep going back and sift through these, maybe I'll start to show a few more that are Like, there's also this X pattern that'll appear sometime. Heck, I'll just keep going back a little bit more. And the X pattern was what made me start thinking maybe this is gravitational waves. But gravitational waves can't exist in the solar system because the influence would be too small, right? Right? Or is it? There's another one, parallel. I keep mixing those words up. Another one, parallel. And this American quake, which are skewed. Another one that's both perpendicular and parallel. Pangaduitan, Philippines. I can't pronounce that. There's a famous plus pattern. And this, I don't know. I would like to say that's perpendicular or parallel. It almost looks like these are all in the off. It's neither perpendicular nor parallel. Yeah, I don't know. I give up on the Americas. They're too weird. But these South America ones, very often they would be like this one right here, perpendicular to the solar system plane. Okay, I should stop. But that's my latest discovery that I noticed while sifting through the data. I'll try to clean up, make sure that my orbital plane is more accurate. And any day now, I should finally be adding some spherical harmonic maps, like hopefully tidal force. I've already got tidal forces from the moon and the sun and whatever other planets, but I should be adding whatever the solution to the tidal force equations, which is supposed to be is this the M1, M2, M3 tidal modes? I want to have tide height around the world because I think that's going to be influential because all these quakes always strike at sea level, even if they're up in the mountains. Even if the elevation of the location where the quake strikes at is in the mountains, like Denver or Central Asia, the quake itself will always be right at sea level. So that's another one that I want to add. And then, of course, a whole bunch of other stuff. But all for another time. Thanks for tuning in, and I'll catch you next time.